In today's video, we are going to look at equivalent expressions and figure out what to solve for when we are giving these equations, and using our knowledge of the laws of exponents that we learned in previous lessons, we should be able to apply those and create an equation that is fairly simple to solve. It's just a matter of remembering the laws of exponents. So one of the laws of exponents we covered previously was when you have terms with the same base, when you're multiplying terms with the same base, you add the exponents. So in this case, if I want to simplify this, this would be x to the 6 times x to the 4th would be x to the 6 plus 4, which is x to the 10th. Now that is the goal, is to have this right side equal this left side. So now this, I have x to the 5, and we're trying to figure out what exponent goes here. Now, knowing the laws of exponents, you would have to, this is a power to a power, so you would have to multiply these two exponents. So I'm just going to call it, I don't know, 5. I don't want to call it x because we're using x in the problem. We'll call it e for exponent. All right, so 5e. So we have a situation where we have x on both sides. We want this to be 10, and this, right, we want this to be 10 as well. Well, you know that whatever you figure out as your exponent, you have to multiply. So you have to do 5 times e equals 10. So you could actually drop the bases. So it becomes a simple one-step equation where you just drop the bases and solve for e, solve for the exponent. Divide both sides by 5, and it is 2. Okay. So that would be my answer. And think, 5 times 2 is 10. 6 plus 4 is 10. So basically, we're trying to figure out what's going to make this equation true by plugging in a specific exponent value. All right. So there's one example of something. Let me try something else. Okay, let's do another one. Let's do x to the 9th divided by x to the 2nd equals x to the 3rd times x to the question mark. Okay. Again, same basis, right? We're going to subtract the exponents when we divide. So 9 minus 2 equals, these we have to add, right? The same base, add the exponents. 3 plus question mark, but I'm going to call it e. All right. And then we simplify, right? 7 equals 3 plus e. Subtract both sides by 3. And you would get, well, these cancel. And you would get your final answer to be e is 7 minus 3, which is 4. So that makes sense, right? 3 plus 4 is 7. 9 minus 2 is 7. Okay, let's look at another scenario. Let's do a different letter this time. Y to the, here we go, 4th divided by y to the 16th equals y to the 2 to the exponent we're trying to figure out. Okay. Again, dividing, same base. When you divide, you subtract the exponents. 4 minus 16. Power to a power, you multiply. So 2e. 4 minus 16 is negative 12. Divide both sides by 2. Those cancel. Negative 12 divided by 2 is negative 6. There's my answer. Okay, so it's basically we're using our rules from previous, the laws of exponents that we have learned, and applying them to create equivalent expressions. All right, sometimes you might see a scenario too where you're trying to figure out if two expressions are equal, less than, or greater than to each other. Let me give you an example. Let me do this. We're going to do x to the 10th times x to the second. I'm going to do times like this. Sometimes you might see it like this. And we're going to see how that compares to x to the 3 times 4. All right. So this right here is what we're really trying to determine. This, how do they relate? Are they equal to each other? Is one greater than the other? Let's see. So x to the 10th times x to the second is x to the 10 plus 2, which is x to the 12th. All right, let's see this side. Ooh, we got power to a power. We multiply 3 times 4, which is also x to the 12th. So both are fully simplified. They are equal. So your answer would be equal. All right, let me give you another scenario. Let's do x to the 10th. Divided by x to the negative 2. And over here, I'm going to do x to the 4th times x to the 4th. Again, we're going to see how they relate to each other. Is one greater than the other? Again, we subtract. Be careful. 10 minus negative 2. So 10 minus negative 2 is the same thing as 10 plus 2, which is 12, right? Forgot the x here. X is 12. All right. This over here, right? 4 plus 4, which is x to the 8th. So it looks like this one is greater than this one. So this one, your answer would be greater than. So sometimes they're not equal. Sometimes you have one less than the other. Sometimes you have one greater than the other. Okay. Let's do some more complex ones with negatives, kind of like the ones we did at the beginning of the video. Use a different letter. Let's try, use a different color too. Let's try n. N to the negative 8th. That's an ugly 8. Times n to the 6th. Okay. And we want to figure out when it's equal, when you have n to the negative 10th divided by n to the question mark. Okay. Sometimes it might help to put the line down the equal sign so you separate both sides. So these both have the same base. So we're going to add the exponents, right? Negative 8 plus 6. And that is negative 2. All right? And then over here, we have negative 10, and I'm subtracting. We don't know what that is, right? So negative 10 minus whatever e is, right? Oof, it's going to be a little ugly. It's okay. We can figure this out. Just bring everything down. Make sure you keep your equation nice and neat, and so it's easy to read. To get e by itself, we would have to add 10 to both sides. Boom, boom. And you get 8 is negative e. Divide both sides by, now you know there's a negative 1 here. Oop, didn't want to do that. Now I'll just scroll this up. You know there's a negative 1 here, so I have to divide both sides by negative 1. Right? So these would cancel, right? These canceled from before. 8 divided by negative 1 is negative 8. So my exponent is negative 8. All right, same thing over here, right? Negative 10 minus negative 8 is going to be negative 2, which would be what you get over here. All right, one more little complex one, because I knew I threw in some negatives. I got to throw in all negatives, see if we can figure this out. All right, let me do a different lever. Let me do m. M to the negative 4th divided by m to the negative 2nd. And we're going to see what equals that when you have m to the negative 20th to the question mark. Again, divide. Just because it looks like this, it's still divide. So you subtract negative 4 minus negative 2, which is the same thing as adding 2. This one, we get negative 2(1e), times e, right? We don't know what that is. Okay. Negative 4 minus negative 2 is same thing as negative 4 plus 2, which is negative 2. And then if I want to get e by itself, you divide both sides by negative 20. And 20 doesn't go into 2, but that's okay. You can have a fraction, okay? Just remember, okay, these cancel. A negative divided by a negative is a positive. So my e is, at the end, my exponent is going to be 2 over 20, which I can reduce to, if you divide both the top and the bottom by 2, right, 1 over 10. So you can leave it as a fraction. So this has a fraction of 1 over 10. Okay, so it's okay to get fractions, it's okay to get decimals, and as long as they're simplified and you show your work, that's all that matters. All right, so that's it for today's video. Thank you for watching, and always remember, whether you're solving for X or for Y, always give math a try.